Welcome to Astronomy, chapter number 9. Now, this chapter is entitled Vagabonds of the Solar System. Now, that title is very appropriate because what we're going to look at is basically all the other stuff that isn't really considered a planet. Right? We've looked at the formation of the solar system. We looked at the Earth and the Moon. We looked at the other terrestrial worlds. Then, of course, we looked at those outer giants. Now we're going to look at sort of the what's left over, the leftovers. And this chapter is going to have basically 4 areas that we're going to look at. We're going to classify all the other stuff into 4 different areas. And those 4 different areas are going to be dwarf planets, which is a relatively new classification since 2006. We're going to look at asteroids. We're going to look at comets. And then we're going to look at meteoroids and meteorites. And meteors as well, I suppose, if you want to think of it that way. But these different areas, we kind of break them apart based off of size. Right? And a dwarf planet is the next closest thing to a planet. And of course, for about 75 years or so, Pluto, one of the largest dwarf planets, was considered a planet because we thought it was the only one like it. We now know, thanks to some great technology, that there are many planets out there, or many planet-like objects. They are dwarf planets. And actually, Pluto, believe it or not, was not the first one of these discovered. There's another one called Ceres, which has been reclassified many times. It was once called a planet, and then it was called an asteroid. It was called a minor planet. Now we have a set definition, but the set parameters for this is a dwarf planet is an object that is not large enough to clear out the area around its orbit and around the sun. And so they talk about dwarf planets here, especially with Pluto. One of the unique characteristics of it is that it has a moon that's basically the same size. And so that moon named Charon was discovered has been known for quite some time. But this object is why it's so difficult to study Pluto is because it is very far from the sun. Now, what's amazing about this is in this book, if you look at this picture on page 285, you'll see that this is we have the 9th edition of this book of Discovering the Universe. And as of when this book was printed, these are the best images we have of Pluto taken by the Hubble Space Telescope. This will change in the year 2015, depending on when you're watching this video. This is all about to change. Right now, as I'm recording this, we're about a year or so away from a project called New Horizons. New Horizons is a fantastically exciting project that is going to approach, that is flying, it is on its way, traveling there now, headed to go study Pluto, and going to give us a really good idea about what is going on with this dwarf planet. Exciting, exciting area. Never before have we seen what's going on with Pluto. Its surface will be revealed in great detail before long. Now, it turns out that Pluto is not the only dwarf planet. There are many large dwarf planets, Ceres being one of them. And Ceres is unique because it is a dwarf planet in the asteroid belt, meaning it's about, in that the asteroid belt is the region between Mars and Jupiter. So Ceres is relatively close. Right? All of the others that we have found are in a region we call the Kuiper belt. Right? The Kuiper belt is the area beyond Neptune, way out there. So when you're going through and doing your reading on this, make sure that you make that distinction. Ceres is the only dwarf planet we classify on the inside, and then, or at least it's the largest one we classify on the inside, and then Pluto is much farther out there in the Kuiper belt. So that is a neat part of what's going on there. Also in here, Ceres, as of the time of this movie, is about to be studied in greater detail by a mission called Dawn, and they mention that up here in the reading in the year 2015. We'll get some great information about what Ceres is made out of. So really in the year 2015 is going to be exciting for dwarf planets. It's like going to be the year of the dwarf planets because New Horizons and Dawn are both going to be looking at these two dwarf planets at the same time. So it'll be very exciting to see what's going on. And really, this is a great point about astronomy. Is our understanding of astronomy is changing right now. As we're going through this, what we know about how things work still continues to change, even things that are relatively close to us. So the point, though, that I want to make to close on with dwarf planets is that this region out here in the Kuiper Belt, far from the Earth and far from the Sun, we're talking like 30, 40, 50 astronomical units from the Sun, is where we find the Kuiper Belt. Most of the dwarf planets we have found are in the Kuiper Belt, far from the Sun, and they are small, rocky, icy planets, planet-like objects. They're spherical, but they're just not quite big enough to clear out the area. So we call those a dwarf planet. Real quickly, on 288, they show you a picture of Eris. And as of the time of this publication, Eris was the largest known dwarf planet. Eris was really the interesting one, because Eris was the object that was discovered that is larger than Pluto out in the same region as Pluto. And this object was found by a gentleman named Mike Brown, working for Caltech using the Palomar telescope. And he chose the name Eris because it was the name of the Greek god of discord and strife. Because when he found it, this was called the 10th planet. We now know that this whole discovery unraveled, and now we no longer call them planets. We call those objects dwarf planets. So it was a time of great upheaval around the early 2000s when we were finding these objects. They mentioned several others in there, Maki and a couple others. But Eris was the one that was bigger than Pluto, and so that's why it got a lot of attention. It caused us to change our understanding about what is actually a planet and what we now call dwarf planets. Okay, moving on to asteroids. Asteroids are the next largest thing, and the thing you need to know about asteroids is asteroids, almost all of them exist in a region between Mars and Jupiter's orbit. Very, very few exist elsewhere. The largest majority exist in this region here, represented by the green. Now, what this diagram is showing you on the top of page 289 is that the green, every dot on there, if you zoom in here and look closely, you can tell that there's a lot of dots, right? Every little dot represents a known asteroid. The green ones represent asteroids that never cross the orbital path of the Earth. The red ones represent the asteroids that do at some point cross our path. Now, the reason why that's all interesting is because, of course, anything that crosses the path could potentially cause an impact with the Earth. So this is a very exciting thing for us to study, and a very practical thing for us to study is what would be going on if one of these were to run into the Earth. So what this means is the green ones are ones that we don't worry about so much. The red ones are ones that we keep a very, very close eye on to see if they could ever run into the Earth. So that is a little bit about the major parts of the asteroids. Now, the asteroids themselves are a variety of unique shapes. Dwarf planets look like effectively tiny planets, and the name dwarf planet was chosen because it is just like a planet, only in miniature. If you think of, like, say, a dwarf goat is like a miniature version of a goat, well, a dwarf planet looks like a planet, it's only smaller. Asteroids look different. Most asteroids are shaped like this, and the description is usually potato-shaped. They are irregularly shaped. They're not spherical. And so what this is that these are also an order of magnitude smaller. So we're talking about things that, instead of being the size of, say, small moons or small planets, these are the size of maybe like a state of the United States, or maybe down to the size of, say, counties, right? Something on that order. So this is much smaller, maybe the size of a small country. These are objects on that order, that scale. But asteroids are affected greatly by Jupiter, and they go into some explanation about Jupiter and its effect on the asteroid belt and how it causes them to move around. And what we know about asteroids we fortunately are able to observe them in great detail because they are close and they are relatively easy for us to see. Now, stepping out, going in a different direction, is to talk about comets. A comet is a lot like an asteroid, except for one major difference, and that is comets have a very high percentage of ice in them. And so that high percentage of ice comes into play when the comet gets close to the sun. That ice begins to change from a solid form into a gas and creates that very telltale tail behind it. So the tail of the comet is made from the ice that is within it. But one of the things we know for sure about comets is comets are not locals. Right? Comets come from way out in the solar system, at least as far out as the Kuiper Belt. And so the Kuiper Belt is, 40, 50 astronomical units all the way out to an area we call the Oort cloud, which is even tremendously farther away. But this motion of them bringing them into the inner part of the solar system is very exciting because it creates this beautiful long tail and gives us this thing to look at in the night sky. And if you're fortunate enough to live on this earth for very long, a good long life, in your lifetime you'll see a handful of good comets that you can see with the naked eye. That is no additional magnification needed. But there will be many others that will be not quite bright enough for us to see. A great example of this was 1997 with Hale-Bopp, or Halley's Comet. That was great in the early 1980s. And these comets that we have seen that have been put on a great view, and certainly as time goes on, we'll see more of those. But this tail is what is so intriguing out of comets. And they show you this on the top of 299, and really here's the better diagram down at the bottom, talking about how there is a tail of dust and a tail of ions. That is the icy material that is being ionized by the energy from the sun. And so they kind of explain a little bit in here why we see these two tails that break off, because of the effect of the sun causing this material to be ionized, and because it is literally falling apart, crumbling apart. And what's neat is this dust tail ultimately is what ends up causing our meteor showers, and we'll get to that in a minute. And then they talk on like 300 about comets are fragile, and they don't last forever. That is, they can only go so long. And very often a comet, when it comes into the inner part of the solar system, is destroyed in that path around the sun, because it gets so close it has the potential to be destroyed by the sun. Now, the last section in this chapter is talking about meteors, meteoroids and meteorites. What are the differences? You should know these definitions. One is in space, one is in our atmosphere, one is on the ground. That's the difference between them. And meteors actually are very interesting, a very neat world to look at, because meteors are, of course, when these things are found on the ground, are quite valuable. They're worth a lot of money. And so a lot of people think, well, I found a neat looking rock, maybe it's a meteor. Well, very rarely is it actually a meteor. I've looked at a lot of neat rocks that people have given me, and very, very few of them have I ever thought even had a chance to be a meteor. So make sure you do some good reading about that, about the different types and how we distinguish them. Last thing I want to give you is the idea that, well, the last thing I want to give you is what we have on the end of the chapter is on a potential impact. Asteroid impacts are very exciting and have created a lot of damage in the past. But the real wild card in all of this is the idea about what can we do to predict them, and what can we do to prevent them if this were to ever happen. So, of course, this is an area of intense study, and make sure that when you're going through this chapter, when you're doing your reading, and take a look at the PowerPoint that'll get you ready to do the assignment for Chapter 9. So good luck.